Hi, welcome to Mathematica. This is Saritha. Today our topic is triangles and congruency. So we'll first know what is congruency. So when the two figures are given, when we call them as congruent to each other. So we'll see the first what is mean by congruency. So what is congruency? See, if you take any two geometrical figures, whatever may be the geometrical figures, they are said to be congruent if they have same shape as well as if they have same size. These two must be followed. Then only we can say those two figures are congruent to each other. See what they have to follow? They should have same shape as well as they should have same size. Yes? See, if you take any two geometrical figures, whatever may be the geometrical figures, whether they may be line segments, they may be angles, they may be triangles, they may be squares, whatever they may be, the conditions they should follow are the two sizes must be equal, two shapes must be equal. Then only we can say the two figures are congruent to each other. So how we represent congruency in the symbol? So this is the symbol we use for the congruency. In order to represent a congruency, we use this symbol. Okay. Okay. So now I'll take two figures. This is one line segment, AB line segment, and this is another line segment, which is PQ line segment. Now tell me, are they congruent to each other? See, they have both have same shape. Okay, fine. So, are they same size? No, right? This is a smaller length. This is of a smaller length. This is of a bigger length. So, somewhere here we take this is a 5 centimeter and this is 8 centimeters. Can we say these two are congruent? No, right? Because they may have the same size, same shape, but the size of the two line segments are different. That is why these two line segments are not congruent. So you take one more line segment. This is some RT. So this is also of 5 centimeters. Now tell me whether the AB line segment and RT line segments are congruent to each other. Yes, they are. Why? Because these two are line segments. Yes, both have same shape. And these two are of 5 centimeters length only. Means they both have same size. Yes, they have equal shapes. They have equal sizes. That is why we call these AB line segment. This AB line segment is congruent to RT line segment. Isn't it? But here this AB line segment is not congruent to PQ line segment, isn't it? So in the line segments itself, sometimes we are saying they are congruent, sometimes we are saying they are not congruent. So that is why if the statement is given like this, any two line segments are always congruent. Is it true or false? You have to read the sentence properly. Any two line segments are always congruent. It is a false statement. If they give the statement as any two line segments of same length are always congruent, then it is a true statement. Did you understand the difference? If they give any two line segments are always congruent, it is false, because just now we have seen these two line segments are congruent, these two line segments are not congruent. Sometimes they are congruent, sometimes they are not congruent. That is why Any two line segment need not be congruent. Need not be means sometimes congruent, sometimes not congruent. We are not sure about congruency of any two line segments. When you come to the statement any two line segment of same length, that time you can blindly say it is a true statement. Yes, any two line segments of same length are always congruent to each other. Now we'll check in case of circles. Congruency in case of circles. You take two circles. This is one circle and this is another circle. Okay. Now tell me, are these two congruent to each other? Or these two circles congruent to each other? How can we say yes, they are both are geometrical figures, they have same shape. Yes, both are circles, they have same shape. Okay. What about the size? Size also must be equal. The size here is radius of the circle. This is the R1 radius and this is the R2 radius. If the radius of the two circles are equal, then we can say they are congruent to each other. They always have same shape. All circles have same shape. But the sizes is depends on the radius of the circle. That is why, what about if you take any two circles are always congruent? It is a false statement. The congruency of the circle depends on the radius of the circle. So if the statement is given like this, the two circles of same radius, they are always congruent, then it is a true statement. If they give any two circles are always congruent, it is a false statement. You observe the difference. Any two circles need not be congruent. Means if the radiuses are equal, then we are saying they are congruent. If the radiuses are not, radii are not equal, then we are saying they are not congruent. That is why any two circles need not be congruent. Okay. So what about the angles? So we'll see the next figure, that is any two angles. Any two angles. This is one angle, angle AOB. Okay, so this is measuring 30 degrees and you take this angle. This is somewhere 60 degrees. This is PQR. This is the PQR angle. This is the AOB angle. So now tell me, are these two angles congruent to each other? See, okay, they have same shape. Angles they may have same shape. But what about the measurement of angle? This is measuring 30 degrees. This is measuring 60 degrees. Are they equal? No, right? That is why any two angles or need not be congruent. If this measure is equal to 30 degrees, then we can say these two angles are congruent. If this measurement is different, then we are saying those are not congruent. That is why the statement is you take any two angles need not be congruent. When any two angles are congruent if they measure the same angle. So you have to identify the difference between the statements, because in the examination the questions are given in the theoretical. If they want to give the questions in the theoretical format, that time they give four statements. So those four statements are a little difference, four statements with a little difference. That time you have to identify what is the true statement, what is the false statement. So by that only in the options A and B are true, A and C are true. So like that you have to eliminate the statements. Okay. So this will help you a lot in while eliminating the statements. These theoretical statements are very important. Okay. Now we'll see the next. What about the right angles? You take two right angles. Okay. This is one right angle. Okay. 90 degrees. And this is another right angle. Now tell me, are they congruent? Yes, they are always congruent. Why? See, all the right angles have same shape, that is L shape. All the right angles have same shape. Okay. Then what is the measure of an angle? This is 90 degrees and always right angle measures 90 degrees only. That is why all the right angles are congruent to each other. So this you have to remember. Till now we have seen any two line segments need not be equal. Any two circles need not be congruent to each other. Any two angles need not be congruent. But always any two right angles are always congruent to each other. Okay. Next, what about equilateral triangle? See, this is one equilateral triangle ABC. It is an equilateral triangle. So each angle measures 60 degrees. And you take one more equilateral triangle. And this is PQR equilateral triangle. In this also each angle measures 60 degrees. Now tell me, are these two equilateral triangles are congruent to each other? Yes, they have same shape. They have same angles. By this only can we say directly those two are congruent to each other? No, right? See, even if they have same three angles are equal 60, 60, 60, the sides may have different measure. See, if you take this equilateral triangle, this may be 5 centimeters, 5 centimeters, 5 centimeters. Okay, fine. This may be 8 centimeters, 8 centimeters, 8 centimeters. Now, are they congruent? No, right? This is measuring different length. This is measuring different length. That is why we don't say all equilateral triangles are congruent. All equilateral triangles need not be congruent. Okay? Because sometimes they may congruent, that depends on the side of the equilateral triangle. If they give the statement that is any two equilateral triangle of same side, equal side, then we can directly say they are congruent to each other. Otherwise, we should not say they are always congruent. We should say to any two equilateral triangles need not be congruent. Okay. So this is about equilateral triangle. What about any two triangles? Not equilateral triangles, but two triangles. See, this is somewhere 6 centimeters, 7 centimeters. Okay, this is one triangle I am considering. And I am considering other triangle, that is, so these two are equal angles, 35, 35, and this is 110 degrees. So consider this is one more triangle. Yes, this is a scalene triangle because all the three sides are different. This is an isosceles triangle. These two sides are equal. Yes, are they congruent to each other? Both are triangles only. But this is different triangle, this is different triangle. Those two shapes are also different. Yes, those two shapes are different and they are measuring different angles. That is why their sizes are also different. We don't say the two triangles are always congruent. The two triangles need not be congruent. So the triangle congruency depends on the sides and angles measurement. Yes? Yes. Now, what about the squares? Now take any two squares. This is one square I am considering, and this is another square I am considering. Now tell me, are these two squares congruent to each other? All the squares have same shape, but they don't measure always same side. See, this is somewhere 5 centimeters of side length. This is some 7 centimeters of side length. Or they have same size? They don't have same size. That is why any two squares Any two squares need not be congruent. Any two squares are congruent if they measure same side. Yes? So these are all the statements you have to remember carefully. So what are those? I'll write here. I have written all the statements clearly. Any two line segments of same length are always congruent. Any two circles of same radius are always congruent. You underline these: same length, same radius. Any two angles of equal measure are always congruent. Any two right angles are always congruent. Any two equilateral triangle of same side are always congruent. Any two squares of same side are always congruent. Yes. So this is what about uh, any two geometrical figures congruency. Okay. Thank you.